Hi everyone, welcome back to Abra Knowledge channel. Today we are going to discuss about very profound topic. The topic is hypothesis. Right? Hypothesis is one of the critical topic in DMAC, in Six Sigma perspective or in general project management perspective, or whenever you wanted to take the decisions and the decision has to be with the confidence level, then hypothesis is one of the topic which is being coined. Hypothesis, going with the dictionary word, the hypothesis means assumption, and you have some assumption and you wanted to test that assumption. I wanted to prove that if your assumption is good, then that means you're right. If the assumption is not right, that means it's an alternate that has one coin has two sides. Like this, an assumption can be right, can be wrong. Right? Exactly, the word literally hypothesis mean an assumption. Assumption, when you say hypothesis, there are two type of hypothesis, right? One is called null hypothesis, that is called H naught. Null hypothesis meaning like state of innocence, no change, same, all these called like null hypothesis. For example, let's say person A is equal to person B, medicine A is equal to medicine B, like city A is equal to city B, or process A is equal to process B, before process is equal to after process. All of these things called null. Null meaning like no change, right? Perfect. And this marker, blue marker is equal to black marker, right? When it says that, that is called null hypothesis, no change. On the other side, you have alternate hypothesis. Alternate hypothesis is alternate to null, meaning there is a change. Blue is different than black, and process A is different than process B, and so on and so forth. Lot many examples you can say. Person A is different than person B. City A is different than city B. All of these an example for alternate hypothesis. For example, men is equal to women. An example of null hypothesis. Men is not equal to women, or both are having different unique characteristic. That is alternate hypothesis. For all of these you need to prove, right? And how do you prove, right? The value, the p value, the statistic of significance determines everything. If your p value is less than 5%, that means 0.05, that means it is you are going to reject the null hypothesis. For example, let's say you are doing a study of in a college, whether the boys are doing well or girls are doing well, and if you happen to get the value, p value less than, let's say less than 5, that means you are rejecting the null hypothesis. You are proving that boys are different, girls are different. Exactly the same thing, reject the null hypothesis, meaning you're basically accepting the alternate one, right? That's what p value is 1. One of the very easy way to remember is, according to this book, and one of wonderful things is being given, and statistic for manager, and using Excel, Microsoft Excel, and 7th edition, very famous book. In that book it has been written by various people, David Living, David Stephen, and you also have Catherine. So all of these people have written in one of the chapter. The chapter name is 9th chapter, and it also talks about fundamental of hypothesis testing and all that. So in that thing, one of the beautiful sentences being given. It says, many people confuse this rule mistakenly, believing that the p is high is the reason for rejection. If you get the p value is high, that means we need to reject. No. And it says that you can avoid this confusion. You can avoid this confusion by remembering the following. If the p is low, then h naught must go, right? That means if the p value is low, that means alpha is 0.05. If the p value is low, then you need to reject the null hypothesis. That means if the p value is low, then h naught must go. And also this book has given wonderfully how to do it in Excel, and with the formula, whether there is a tail one, whether you have two tail, and whether all of these things it has given with the formula. And this is what it happens when you reject the actually there is something other thing. It has been beautifully, very beautifully explained. There is something called actually the reject null hypothesis, and there is something called actually you are accepting it, but it has to be reject, but you are accepting it. That is called type 1 error. And there is also called you need to accept the null hypothesis, but you are rejecting it. That is called type 2 error. That will come back later actually. That is a different subject altogether. We'll come back later. But this book has given very wonderful synopsis and scenario. For example, one of the scenarios given about the food restaurant, and you are the manager, you are the food restaurant, you are the owning the food restaurant, and it has given that the before time was taken like 5.1 minute, now it is taken like 4.5 minutes. You wanted to prove that there is a difference, right? So how to do it? If the value is p value is low, then you need to reject the null hypothesis. You need to accept that there is a change. Initially 5.1 minute, now it is 4.5 minute. Let's come back to alternate one. Alternate meaning like anything greater than 5%, that is called alternate one. That means you are accepting the greater than 5% is accepting the null hypothesis. Meaning so you are saying that if you are getting the value greater than 5%, that means you are telling that the same, both are same, right? The whatever the claim you wanted to add, if it is same, that means accepting the null hypothesis. Null hypothesis you already know. Null meaning same, no change. You are accepting it. If you are proving that in that particular example which I quoted about the restaurant, and the p value is 0.031, that means only 3%. That means we are rejecting the null hypothesis. We are saying that 5.1 it was taken before, now it is taking 4.5. Bang on, fantastic work, right? This is the way to remember. Very simple. P value is low, then H naught must go, right? That if you remember that, you will be able to understand that hypothesis better. Let's talk about from the tool perspective, right? There, depend upon the type of data, again you can the whole analysis will change, right? For example, you have variable data and only one column you have. You are comparing only one with the different machines of one values you are comparing. That's the t-test. And then 2t means two tail. For example, I think one of the experiment which we have done in the channel is the average batting of Sachin Tendulkar and Virat Kohli. And if you getting the p value, I think we got the p value greater than the 5%, right? So if you are getting it, then you based on the p value you can distinguish what is the result and all that. Exactly the same thing. 2t is for variable, and then you have two sample, let's say process A, process B, before, after, Sachin, Virat. All of these cases you can use 2t. Then chi-square. For example, you say you have a discrete situation in a shopping mall. How many people in the weekdays are coming, weekend is coming, and then the shopping mall has got a different branch across the country, let's say north, east, west, south, or how many female or male. All of these discrete when you have, then you can use the chi-square one. Again, the whole hypothesis, whether t-test, 2t, hypothesis, ANOVA, proper proportions, everything, you get the p-value. From the p-value, you need to take the decision. If the p-value is low, that means you are rejecting the null hypothesis. If the p-value is high, you are accepting the null hypothesis. That's what it means. And then ANOVA, analysis of variances. And then analysis of variances, some of the thing, even if you do it Minitab, if it gives you the mean, it gives you the second column, it gives you, for example, what is the mean, what is the number, what is the mean, and then standard deviation, standard error of mean. And then it also said 95% confidence level, value, lower value to higher value, it gives it. And if you go scroll a little up, right, you will also find that p value also as well. ANOVA also gives you p value. That p value you need to check. The p value depend upon these conditions you need to satisfy. And then there is also called proportion. Again, you have a discrete with a multiple reason. You can use a proportion. Whether it's t-test, whether you have chi-square, whether you have ANOVA, probability based, all of these tools will give you p value. Based on that, you need to take the decision. The last one, the example of p value, and then the hypothesis is taken. Any assumption can be tested. Any assumption, and then let's say you wanted to take an assumption that reading soft copy and reading hard copy is better, right? Then you take the samples, population, from the population take the samples, and then if you're trying to prove that the p value is lower than 5%, that means you're rejecting the null hypo. You're saying that soft copy reading is different, hard copies reading is different, right? So exactly in that, any assumption, any thought can be tested using the hypothesis model. The last the example is, for example, yield percentage you have, and like old hotel rating, and you have a medicine, you wanted to compare the medicine, and you wanted to do a research, and all of these people, hypothesis is very wonderful topic. If you are into project management, if you are into research one, and hypothesis, you can prove it more statistically, you can prove it. That's the powerful of hypothesis. I have covered more of the things using the Minitab also. You can take a look. You will get a better clarity on also as well. Thank you so much. Please do like, share, subscribe my channel. You have wonderful day ahead. Happy learning of hypothesis.